Hi guys, this video documents me modelling a carry-all tray that I'm going to make. It wasn't my intention to make this video, but I thought I've got to model this project anyway. I might as well record and learn from it. So if you're just starting out with Solidworks and you know some basics, maybe you're looking for something simple to model, this video could be for you. You can download the plans for this model, absolutely free from my website to use if you want to follow along, and there's a link for those in the description below. I don't go into full detail in the modeling of this project, so you will be required to know some of the basics of the program, but if you're an absolute beginner, please subscribe and turn your notifications on, as I'll be uploading some beginner tutorials soon, once I figure out how to use the program, that is. If you're a pro, this video is probably not for you, unless you want to watch and leave some comments on what you would have done better, because I am sure there are more correct and efficient ways to complete some of the processes that I went through. If you're looking for industry standard information in this video, forget about it. I didn't do anything to AS 1100 standards or anything like that. It's just a model to give me the information that I need to build this carry-all in real life. If you're a high school graphics teacher, however, this video could actually be a great lesson filler. Even if your school doesn't have Solidworks, with a little bit of lateral thinking and downloading those working drawings, your students could model this project on any other CAD software such as Autodesk Inventor or SketchUp or anything like that. Anyway, that's enough from me. Let's get to the modeling already. Righto guys, I'm just about to build a new carry-all project for my workshop. So I've decided to do up a quick CAD model of the project to get all the dimensions I need and create a materials list for myself. I'm using Solidworks to complete this model. I'm no expert at this program and I'm pretty rusty, but if you'd like to follow along, I'll briefly describe what's happening at each stage if you wanted to have a go modeling this yourself. Okay, so I'm starting with side B because it's the most simple part. It doesn't have any joinery really. So all I've done here is created a new part, selected a sketch plane, used the rectangle tool, and I've made that rectangle 328.5 millimeters long and 64 millimeters high. Once that has been drawn, I've then just extruded it to 19 millimeters thick. And that's it, that's side B done. You can save that to your computer or your cloud system if you're using one of those. We'll move on to the next part. So creating a new part, I'm then going to create another sketch, another rectangle. This time the rectangle is going to be 288 millimeters long, 64 millimeters high, and then I'm going to extrude that 19 millimeters again. So this end has a hidden dovetail joint and a rebate at the other end. For the hidden dovetail, I'm going to leave 6 millimeters of material on the left hand side here. Then I'm going to come down 15 millimeters from the top and the bottom, and then I'm going to mark a line using a 10-degree constraint, and then I'm going to use the cut extrude option to cut that dovetail in 19 millimeters deep. From there, I'm just going to flip to the other side and mark out the rebate, which is just a simple rectangle on that face that will be the height of the timber, which is 64, and it'll come across 19 millimeters. Then I will cut extrude that down half the width of the timber, which is 9.5. Then what we'll do is we'll go to the top face here and mark out the female side of our mortise and tenon joint. We're going to come 123 millimeters up from the dovetail side, and then we're going to mark it out basically a simple rectangle that's going to have 6 millimeters either side, leaving a 7 millimeter width in the middle. Then we're going to extrude that out the thickness of the timber, which is 64 millimeters, using the cut extrusion tool. Then we'll save that part as end A and move on to the next piece. And that next piece is end B. End B has a dovetail joint at one end, a butt joint at the other, and a bridle joint in the middle. So again, I just used the rectangle sketch tool and dimensioned that out to 269 millimeters long, 64 millimeters high, and then extruded that 19 millimeters. Then I used the sketch tool again and selected the end grain as a face or a plane to work on. Then I sketched out the dimensions of a dovetail, coming down 15 millimeters from the top and coming up 15 millimeters from the bottom, and then again using a 10-degree constraint on the line tool to create the shape of the dovetail that I want to remove. Then I used the cut extrude tool to remove that piece. Next, I moved on to the male section of the bridle joint on this end. To do that, I selected the sketch tool on the top face of this length. I came in 123 millimeters from the dovetail side, and then I'm sure there was a far quicker way to do this, but I've basically just marked out two areas, 42 by 6 millimeters on each side, leaving a 7 millimeter gap in the middle. And then I used the cut extrusion tool to cut away both sides, 64 millimeters down, which leaves us with the male section of the bridle joint complete. Then I moved on to side A. Side A has a dovetail joint at one end and a hidden dovetail joint at the other. I again just used the rectangle tool in sketch mode and sketched out a rectangle 332 millimeters long, 64 millimeters high, and then I extruded that 19 millimeters. Then using the sketch selection tool, I selected this front face and started marking out the long dovetail joint first. And again, I'm sure there's faster ways to do this, but I just marked out a rectangle that was 19 millimeters by 64. Then on the inside of that rectangle, I came down 15 millimeters and up 15 millimeters. Then again, using the line tool, I created a line on an angle of 10 degrees to create the area for the dovetail. And then I used the cut extrude option to take away those two little outside edges to form the dovetail joint. And on the other end, it's basically the same process over again, except I'm only going in 13 millimeters rather than 19, because this end is the hidden dovetail joint, so it stops before it gets to the end that it joins to, so it is just slightly shorter. Okay, now the sides and ends are completed, we're going to move on to the handle risers. We're going to skip through to handle riser B, and to model this part, again using the sketch tool, choosing a plane and creating a rectangle to start with. That rectangle will be 200 millimeters high and 42 millimeters wide this time, not the 64. And then I'm going to extrude that 19 millimeters thick. Then I will move on to marking out the bridle joint. So I'll select the side face of the riser, and then I'm just going to mark out a little area that is 64 millimeters high and it's 7 millimeters in the middle, leaving 6 millimeters either side. So the part that's cut out of the bridle joint is 7, the two parts that stay are 6. Now I'm going to make the top of the handle riser curved. To do that, I am just going to come down 21 millimeters from the center of the top of the riser and create a circle with a 21 millimeter radius. Then I'm going to use the trim entities tool to cut away the areas that I don't need, to help me cut away the areas I don't need. So I'm creating a bounding box around the parts, then using the cut extrusion tool to remove the excess material. Then I'm going to select that face surface again. This time I'm going to create another circle using the same center point, except this time I'm going to have a diameter of 22. I'm going to create a straight circle, and then I'm going to cut extrude that circle in 9 millimeters deep to have a recessed hole ready for a dowel joint. Now I realize I'm a little bit all over the shop in terms of the order of these parts, so just going back to handle riser A, this is very similar to the bridle joint, except this time we're just doing a tenon joint. So we're marking out exactly the same as the last riser, except instead of taking away the middle of the bottom of the joint, we're taking the outside edges. So we're leaving 7 millimeters in the middle and removing 6 millimeters from either side, using the cut extrusion tool, 64 millimeters deep. Then as for rounding the top over, the same process as before. To start with, we use a 22 diameter circle, and then our line tool, trim entities tool, and extrude cut tool to remove those excess edges. Then we go back and use a circle again, same center point, except this time it's just a radius of 21, and then we're using the cut extrusion tool to go 9 millimeters in to create that recessed dowel joint. On the home stretch now, this one's pretty basic. All I did was created a sketch using a 22 millimeter diameter circle and extruding that 318 millimeters long to form the handle. Now apart from the base, that's all the parts done. Before I model the base, I'll just quickly show you how all of these parts are constrained together to form a completed model. Now everything I've modeled so far are referred to as parts. Now what we need to do is create an assembly. And an assembly is just essentially a combination of all the parts put together to form the full model. Now I'm not going to get into any crazy detail here, I'm just basically going to show you that each part needs to be constrained in 3 directions for it to stay in a static position so it doesn't move around. So as you can see here, I've imported my first part. followed by my second part. It doesn't necessarily matter which order you do them in, as long as you know which part goes where. So first I like to generally move the parts to around about where they need to be in position. Now what I like about Solidworks is that the mate options are pretty intuitive. So if you select two surfaces that you want to be flush, or parallel, or joining together, Solidworks is pretty good at determining which one you need. So as I mentioned before, you need 3 points of constraint generally to stop a part from moving away from another part. So I've chosen the two top surfaces to be flush, the two outer surfaces to be flush, and then the inside edges of those two joins to mate together face to face. And as you can see now, I can move these parts around and they'll all stay together. I will just mention here that I actually joined those faces on the wrong side. That butt joint should have actually had the side piece on the outside of the end, not the way that I've done it now. I do eventually go back and fix that in the video, but I'm just going to speed everything up from this point forward. Essentially, all I'm doing is adding those 3 constraints to each of the other parts until I have a full model. The only difference in the constraints is that when it comes to the dowel rod being inserted into the recessed dowel joint, we are simply selecting the inside of the diameter of the recessed dowel joint and the center of the dowel handle, and that forms the mated constraint. Now, to be honest, I just did a bit of experimenting in this next part. I wanted to see whether you could actually take material away from a live model that has already been completed in the assembly. So what I did is I flipped the model over and I marked out the area that I wanted to remove as a rebate to insert the base. Rather than having to draw all of these cut extrusions from every individual part, I just drew a big rectangle that covered the area that I wanted to rebate in, and then I cut extruded that, and it actually made all of those adjustments to the parts in the live assembly. So that rectangle I marked out there left 9mm of material on the outside edge and took away 10mm of the material on the inside, leaving us an area of 320mm by 270mm, which will determine the size of the base. And I'm going to be using 6mm ply, so I cut extrude that rectangle in 6mm. So now I know those dimensions for the base. The next part was very simple, just creating a sketch with the rectangle tool, plotting out a rectangle 320mm by 270, and then extruding that by 6mm thick, and that's the base done. So from there, I just reopened my assembly file and imported the base part, and using those 3 points of constraint again, I've inserted the base into the assembly, and now the product's complete. So the only thing left for me to do, just to make it look a little bit better, I've just applied some material appearances to each of the parts, and there we have it. That's the CAD model complete. And if you stick around, I will be making a build video of this carryall as I make the project in real life, and that video will be available shortly. Thanks for watching.